Alright, welcome back to Everything in Swift. So let's solve the Leetcode problem and see how it's go. Actually, I have tried this problem by myself, but even though the question is the median, mark as a median, and then the topic is a sliding window, I cannot say that it is a median, it is a hard. If I mean that it's a hard, it's a super hard. And let's run through the question. So even though the question is very quite short, we cannot underestimate like this is an easy question. So the legal question is count the number of substring with the dominant one. So what do you mean by like dominant ones? There is an explanation here. So we're given a binary string s. We will have a like string of s. After that, and then we have to return the number of substring with the dominant ones. So a string has a dominant ones if the number of ones in the string is greater than or equal to the square of the number of zeros in the string. So what they mean by dominant ones is, maybe I will write down the logic in here. It's mentioned like number of one is greater than or equal to numbers of, okay, let's write like this, number of 0. It will be the number of 1 square. So if the condition stated in above is true, that is considered the dominance 1. So okay, let's go through the XML on the XML1. I think that would be a little bit long to explain, but we got times. So let's consider we are having the dominant ones in here. How are we going to calculate that? So to calculate, we will be using the sliding windows. So that's why that problem is called the sliding window problem. So we check like 0 to 1 in here. So if 0 to 1, we calculate based on our dominance of 1 explanation in here. So we have a number of 1 is 0. Okay, let me just drop it like this. So that means like 0. And then we have number of 0 is also the 0. But 0 power 0 is 0. So 0 is equal to 0. That means we can consider this is the dominance of 1. So we will mark as a green. And then next step, how we're going to do is we go through like this. So this is the second index. A substring is something like this. So which is now this time we got the 2 0. Oh wait, I make a round explanation. So since the number of 0 is here is a 1, so 1 power 2 is 1. So 1 is less than 0, which is false. So that would be the red color. That means this is not the dominant for 0. It's a dominant for 1. And then, so we go through the second item, which is the second substring. So we go like, this time number of 0 is 2. So 2 power 2 became the 4. So that will make us stay red in here. And then next step, what we're gonna do is we go through like 000. So it's a 3 power 2 is a 9. So stay false. So that makes us like not the valid one. So if we go like this, it's a comparison between like 9 is it's that 1 is greater than 9, which is also false. And then we go like this, 9 is greater than, it's like 2 is greater than 9, which is still false. And then we move through the next item, which is this second subarray, which is in here now. So if we do this, we will check the same. It's invalid, 2 0 also invalid. gonna have is because okay, number of 0 here is a 1, so 1 power 2 is 1, so 1 is equal to the 0, which is false. So the same, even though the number of 0 is slightly increased, this will be not the dominant one, since we need the more ones in our subarray. So we go through like 0 to here, and then there's a 1, so 2 power 2 is 4, that means like 1 is greater than 4, that is false. And then next, that is literally where we got that equalism. So because we have a number of 0 is 2, 2 power 2 is 4, but still number of 1 is only 2, which make us invalid. So we move to this index in here. So to move the index, we now calculate like this subarray. Let's got this subarray in here, 7. Not 7, it's just a 7 is a number here. And then we calculate like 0, so mean 1 power 2 is 1, and then this is 0, so it's stayed invalid. And then we calculate like this item here, so 1 power 2 is 1, and then 1, that make us a very valid first item here. I will mark this as a green color. And then next, what we are going to do is 0 to 0 and double 1. Double 1 means a 2, so 1 power 2 is 1. That means that's a valid point. And then the last will be like this. Yeah, so we calculate like 1. So 1 is so number of 0 now this time becomes 0. So 0 power 2 is 1, and the 1 that's make us true. And then next step we go like 1 1. So 2, number of 1 is 1, number of 0 is 0, 0 power 2 is 1. Oh wait, 0 power 2 should be the 0. Silly Mac. And then that makes sense because we have a number of 1 is 2, which make us invalid. And then the last item in here, so number of 1 is 1, number of 0 is 0, 0 power 2 is 0. So that makes sense. So after we calculation of these 5 gram subarray, that is the answer in here. So we need to find like this approach. So to do that, my ideal case, what I can think of is we're going to count the number of 0 index in here so that we can easily switch the subarray index, because this we just see in example 1. What about example 2? So in example 2, so the zeros are in between of the ones. So that means like we should be able to swap the index. Instead of like swap, we need to be able to switch our swap subarray index very quickly, so that we can save a lot of performance in here instead of like becoming them. Even though we will solve the problem in O of n square, but we still will keep some of the process that is not required for us to compute again and again. So to do that, let's use the variable called characters, and okay, just saying we'll use the array of s, so which began the character arrays, and then we have let's use n. So I make a promise to myself since the yesterday video. Every time I saw the arrays, I will just use the n to count. So let's call s.count, which is a total number of items in our character arrays. Now what I want to do is I want to calculate the 0 position, which will be 0, 1, 2 in here. Now plus, what I'm going to do is I want to add the centimeter value. What do you mean by centimeter value? So which is the index. Let's go 0, 1, 2, 3, 4. Now I'm going to add like centimeter index in here. So that number of position for 0 will be 0, 1, 2, and 5. So I will let you know why we need the centimeter values in here. Okay, let's call like 0 position, and then we have an empty array initially, and then I'm gonna do is iterate to like 0 to the end of the n, and then we just check like a symbol like better call this as an index since I use a lot of single character variable names, which is not good for the coding. And then we will check if it is equal to 0. What we're gonna do, we're gonna append our position to the 0 position. That's what we want. So we have received like 0, 1, 2 in here. And then in that case, for the example 2 will be 1, 4, and 6. We will add the 1 centimeter value, which will be in here. So now we have done for all these 0 position in the array. We still need to add that centimeter value. How do we add it? It's quite straightforward. So after we receive the 0 position array, we just append the size of the array, which is n in here. So we just call like add the centimeter value. And then let's call like we have put the zeros in here. Let me think. I will need the zeros in the whole thing. So no. Yeah, let's call like total zeros because I don't want to calculate the 0 position dot counts throughout the program. So let's call it as a count. Now we still need the one variable for sure to keep track of the answer. Which will be initially the 0, and then let's use a pointer, which is originally the 0 index. That we will keep our pointer start from here. And then let's go through the pointer and see how. So let's call like start, since we're going through the pointer. So in 0 to the end of the index. So what do? We will check like pointer is less than to the 0. What do we need to check? We don't want our pointer to go more far than the total number of 0. So let's consider we have a total number of 0 is false in here, since we have a 1 centimeter value. We don't want our pointer to go over this. So even though we have 4 value, we don't want the pointer to begin the fight. So that is to keep track of index out of bound errors in our program. And then we next condition we need to consider is we need to keep track of the 0 position pointer, which is less than for the start. So what does that mean? So we have a 0 position pointer maybe somewhere else in here. Let's duplicate it. I will make a color in blue, which is a 0 position index, and then I will check the start is always greater than our 0 pointer. So something like this, because the reason why we need to keep track of that 0 position pointer is if we know the last item of the sub-array from the previous sub-array, we can easily switch back to the next sub-array by adding the +1 to the previous sub-array last item. So that is the reason we keep track of the 0 position pointer is less than the start index. So if it's true, we're gonna +1 to the pointer. So if this is within the range, mean like pointer is less than 0 count, that's true. And the next is our 0 position pointer, mean like one of the index in the 0 is less than the start. Then we are in here, somewhere around here. So after that, we will move the pointer to here. So that is our pointer. Let's call like red color. We'll move to there. So which will create the sub-array for us, which is like this. But this is just an XML with a centimeter value. But there is a bad XML. But it's something like we are creating the approach like that. So after we go through for the pointer incremental, we need to do is we need to keep track of the 0 count. Let's call like 0 count. The variable of 0 count should not mess with the variable of total 0. Just initial values in here. The 0 count in here means we want to keep track of 0 in a subs array starting at start. So let's call like 0 initially, and then we need the let's calculate position, and then which will be the start. So that means every time we have a start index, which is the initial index of the subarray, that will be the let's calculate the position. So in here, if I have to demonstrate about the let's calculate the position, start will be, let's say we are going through the index of 3 and 4 subarray. Our let's calculate the position will be here, which will be 0, since there is no valid dominates one subarrays in above. So for the next step, what we need to do is we need to, okay, I will need the one variable. Let's consider like index again. So the index will be the pointer. So that is the key in our whole solution. So which will be going through around the subarray. Let's create another color. Here, let's consider using the black color. So which is a pointer. And then that index, we also need to keep track to not to begin the index out of bound. So that's why we need another while loop. So if index is less than the total 0, that means we are in the correct subarray. If not, we don't need to think about it. And then I can just return the answer in here. After this, in Y, what do I need to do is I want to update the position. Just want to keep track of the position of the 0 position. Let's call like index. So since we are using the index as a pointer, so let's say our pointer is here, we want to use the pointer of the 0 index. That will create the subarray like this. Okay, I'm gonna move it to the better idea for you guys, like this. And then we are now calculating like this array, this subarray in here. So after we have calculated 0 position, what we do is we will check to our very base case, the number of 0, square of the number of 0. So we can simply achieve by multiplying the 0 count twice and then which should be the greater than n. That means it's no longer valid. So we're just reversing the valid points in here, and then we can just break in here. So we don't need to continue through the while loop. Since the condition is round, why do we need to continue it? So next is we need to calculate the, let's call like minimum n. The reason why I call the minimum n is we should have like one pointer going around here. So maybe this one, maybe like this one. So the minimum n is the black color one, which is going through in here. So if the minimum n, I will use approach like math. That will be a little bit like mathematical approach for you guys. So that is simply we are going through calculation of n index of the subarray for every start position of the start subarray. So the mid n in here means we are trying to calculate all the n index of the subarray. So that's what we are doing here. So it should be the start that's a 0 count, and yeah, then we need the square of the 0 count, since we still need to calculate about it. 0 count, and then just detect the -1 for our centimeter values in here. And then next is we will calculate with the less calculation, calculate the position. So after we receive the minimum n, so we gonna compare like if minimum n is less than our position, which is a 0 position in here. So we gonna increment the answer by removing the position from minimum n. Yeah, and then we can just simply apply like let's calculate that position will be the position, which is a 0 position, and then we're gonna increment the 0 count to plus equal 1. So that means we are moving from the 0 count to the plus 1, and then we're gonna increment the index to the plus 1. I think that's pretty much to solve the problem. Let's run through it, see how I make the typo or not. Exactly on the line number 36. What did I make a mistake in here? Oh, I am missing the index variable. Oh, wait. I am not missing anything. Why it's like that? Maybe the duplication of the variables, probably. I think something missing here. If this, why? What did I do wrong? Oh, just missing the space. All right, that's a little bit restricted static type language. In the line number 9, there is something wrong. All right, that's not array for sure. That's a function. Let's run again. And then we have issue like minimum n. Wait, I just created minimum n variable just right of that for you guys to use it. What did I do wrong in here? Oh, should be the minimum n, not the mid n. All right. Sorry for making a lot of typo. I was trying to describe how I understand the problem to you guys so that you guys can focus on the solution instead of the code base. I think the time complexity wise will be O of n squared. Yeah, since we have a 2 next step loop in here, and then the space complexity will be O of n since we only use one array, which is a 0 position array in here. Yeah, I think it solved the problem. Let me see how many people. All right, even though today is medium, it's a little bit hard question. There's around 2,000 people trying to solve the problem, and you are watching the video if you're one of them. And congratulations, and see you in the next video. Bye.